So, good morning to all. Our today's discussion is on Wilcoxon sign rank test for large samples. How we use this test situation where large samples occurs. Okay, that means if the sample size is more than 30, that is the conventional technique we are following in testing of hypothesis. Then we use normal tasks. Okay, we assume that the normality assumption is there. Okay, so for large number of observations, after discarding zeros, that means you just subtract the given value from the observations and check the plus and minus signs, including the zero signs. You subtract the zero signs from the total size, then that size is called the sample size. Okay, suppose this sample size is large, then we follow some normality assumptions for our test statistic T. Okay. You know what is T? T is our test statistic. It is the minimum of T plus and T minus. Okay. T plus means sum of positive ranks and T minus is sum of negative ranks. Okay. Now, for the normality assumption, we need the mean of these observations and its standard deviation. Okay, here the mean is denoted by mu t, and mu t. It is given by n into n plus 1 by 4. That is the formula for finding out the mean of these ranks. Okay, and its standard deviation is the formula root n into n plus 1, 2n plus 1 by 24. These derivations are coming from the assumptions of binomial distribution. Okay. You are familiar with the binomial distribution. So, using this mean and standard deviation, you have to standardize or you have to find out the set values for these score values, these rank values. Okay. So how to define set? Set, set is standard normal distribution. Is mean minus, observation minus its mean divided by its standard error. Okay, or standard deviation. Okay. So here set is equal to T minus mean. Mean is mu T and divided by its standard deviation. T minus mu T by sigma T. Sigma T is denoted for standard deviation. And you know that this set follows normal distribution. Okay, set follows n0, 1. So using here we are using set distribution, standard normal distribution. So using the standard normal table, you can find out the critical values. Okay. So to familiarize these techniques, we may look a problem. This example says that to test the claim that the median age of mathematics faculty in the state community college is less than 42 years. A survey from randomly selected samples of 32 mathematics faculty yields the following age. Okay. Their age is given. So age is 56, 62, etc. up to 38. These are the ages of 32 mathematics faculties. So the sample size is 32. Okay, 32 observations are there. And our assumption is whether the median age of mathematics faculty is less than 42. So median, you are assuming that median is 42. Median age is less than 42. So given value for median is 42. So using that, you can follow. The question is use the Wilcoxon sign rank test. For level of significance alpha is 0.05. You may test this situation using classical method and p-value method. P-value means probability value. This is usually using in a software methods. If you apply this data, if you use this data in software, you can easily find out the p-value. This is another technique, latest technique, but for the in your syllabus, we discuss only classical method. Okay. So what is classical method? So first we know different steps procedures are there. Step one is null hypothesis. Here null hypothesis H naught is eta greater than or equal to 42. Okay. Alternative is eta less than 42. Alternative means your research hypothesis. Research hypothesis is eta less than 42. Okay. Now here uh, here eta naught is, what is eta naught? Eta naught is 42. So the first you have to in the step 3 you have to fix the level, and step 4 you have to find out the deviations of observations from the given median value. So these are the deviations. You just subtract this value from the observations. So what about the first observation? First observation is 56. So 56 minus 42, that is 40. In that way, you subtract this 42 from these all observations, 30 observations. Okay. So now 32 observations. Here you have 32. In this problem, you have 32 observations. So you will get 32 difference values. And by looking these values, you can see that some values are positive, some are negative, and some zeros are there. Okay. So to find out the exact sample size, you may discard these zeros from the total sample size. Total sample size is 32. Here, how many zeros? Only one zero is there. So you subtract 1 from 32. So remaining is 31. So the sample size n is 31 for this situation. Okay. Now next you may find out the rank for these difference values. For that you consider the absolute value of all these observations. Don't bother about the sign of these values. You take the absolute value. You take the magnitude of all the observations and arrange them in ascending order. You have given the ranks for these observations. Okay. So how to give the ranks? Here the least value is 2 or minus 2, minus 3, 3, etc. Okay, these are the values. Now assigning ranks to them. Okay, for the first value, that is minus 2. You consider its magnitude only. So the first value is 2. So for 2, you put a rank 1. Then for 3, how many 3's are there? Including this minus 3. Because you are considering the absolute value. So 3 3's are there. So their ranks are 2, 3, 4. Okay, 2, 3, 4. So 2, 3, 4. 9 by 3. 9 by 3 is 3. So assign 3 to these 3 observations. Okay, and put the negative sign for negative difference. And next rank is, this is 1, 2, 3, 4. Next rank, how many observations? 5, 6, 7. 5, 6, 7. So it is 18. Sum of ranks is 18. 18 by 3. 18 by 3 is 6. So you put 6 for these 3 observations. That is why 6 here. Okay. In that way, you supply the ranks for each and every observations. Now consider the positive ranks, and you separate these all observations into 2 groups, positive ranks and negative ranks, and find out the sum of these ranks. Then positive ranks are these values 3, 3, etc. You find out these positive ranks and sum all these values. The total sum is 239. 239. And you denote that sum is T plus. T plus is sum of positive ranks. Similarly, find out T minus. T minus is sum of negative ranks. That is 257. Now, what is test statistic T? T is smaller value of T plus and T minus. Which is the smaller value? Here 239 and 257 are the 2 values. So the least value is 239. So you take 239 as your test statistic. Okay, and the number of sample, your total sample size is 32, and you subtract 1 because 1 difference is 0. So the remaining is 31. So sample size is 31. and here the size is more than 30. That is why we are following the large sample technique. So the large sample technique says that the test statistic, the new test statistic Z is T minus its mean by standard deviation. And this follows normal distribution, standard normal distribution. So you have to find out what is mean and standard deviation. What is mean? Mu T is n into n plus 1 by 4. N into n plus 1 by 4. That is 31 into 32 by 4. That value is 248. Then similarly find out sigma t, standard deviation. Using the formula, you will get standard deviation is 51.03. You substitute these two values in the derivation in the formula for set. Okay, set is equal to t minus mu to t. We have already find out t. The value is 239, and you substitute this value here is 239 minus 248 by 51. So compute that value. That value is minus 0.18. So here the value obtained for test statistic is minus 0.18. Now we use the critical value. That value will be obtained from the standard normal table. Here for set is our assumption. You check your alternative hypothesis. You can see that this left tail. Alternative is left because we are using less than or equal to inequality. It is left tail, and the level of significance is 5%. So you use the standard normal table for one tail test. For one tail, you are aware of the standard normal table. The values are given for two tail and one tail. Then how to find out one tail or two tail? Based on alternative hypothesis. Okay. So here the table value is 1.645, and we give a negative sign because it is in the left side, and our obtained value is minus 0.18, and you can see that your calculated value is less than minus 1.645. Okay, so what about your since your calculated value is less than the table value, you accept your null hypothesis. Okay, so the data does not provide sufficient evidence against the null hypothesis that the median age of mathematics faculty in that college is greater than or equal to 42 years. Okay, and this is the conclusion of that exam. Okay, I think you can follow this problem. Now we may move into another section. So we have discussed Wilcoxon test, Wilcoxon sign rank test, and we see that this test can be applied for a small sample and a large sample. Okay, and you have seen that Wilcoxon sign rank test is also applicable for paired observations or dependent observations. Okay, for dependent observations, we can use Wilcoxon sign rank test. But there may be situations where the variables need not be dependent. That means the variables are independent. Okay, independent situations. You consider two set of data and two of them are independent. No dependency is there. For testing such a type of situations, in parametric test, you are following t-test. T-test, you have two alternatives for t-test, paired and unpaired. So paired t-test is for dependent observations and unpaired t-test is for independent observations. Okay, here in non-parametric test, instead of paired test, you use Wilcoxon sign rank test, and for unpaired t-test, the alternative is Mann-Whitney test. So Mann-Whitney test is used for independent set of observations. So what is Mann-Whitney test? Okay, so I told you that the Wilcoxon sign rank test can be used to compare two populations when the two sets of samples data are paired. Paired means they are dependent. Suppose there is no natural way to pair up the data values, that is the sample are independent. Sample are independent. Then man-Whitney test is the suitable test for that situations. Okay, and it is most widely used test as an alternative to the unpaired t-test. Okay, is an alternative of unpaired t-test. Now here for man-Whitney test, it is also called the man-Whitney U test. Okay, the test statistic is U. U is the statistic used for man-Whitney test. In Wilcoxon, it is sum of signed ranks. T is using as the test statistic in Wilcoxon or signed rank test. But here in man-Whitney, the test statistic is U. So how to find out U? Suppose x1, x2, etc., xn1 and y1, y2, etc., yn2 be two independent set of random samples. Here n1 random samples from the first set and n2 from the second populations. For independent random samples, n1 and n2 need not be equal. But for paired samples, size should be equal. For two sets, that size should be equal because they are dependent. For independent, it need not be equal. So for first set it is n1 and for second set n2. From two populations with the PDF f1 of x and f2 of y. So we want to test if the samples have been drawn from the same population, that is f1 of x equal to f2 of for all x. Okay. So the man-Whitney test uses the sum of the ranks, that is t. To assign rank to each observation of the two samples, we combine the two samples into a single sample as proceeded in the Wilcoxon sign rank test, and arrange the observations of the combined sample in ascending order of magnitude and put the ranks to them. Then find out positive ranks and negative ranks as the technique we followed in the Wilcoxon sign rank test. Here let Tx. Tx means sum of the ranks of observations of the first sample. First sample is x values. Okay. Sum of the ranks of the observations of first sample. The Ty means the sum of ranks of the observations of second sample. Okay, second sample. So here we have two sets of samples, x samples and y samples. So find the sum of ranks of Tx, then sum of ranks of Ty. Okay. For finding ranks, you have to combine all the observations, all the two groups, x and y, then split the ranks into two groups, for the x group and for the y group. Now, the U statistics, man-Whitney U statistics is defined as follows. It is you have two U values. For x observations, you have one U value, it is called Ux, and for y values, you have one U value, it is called Uy. Here Ux is Tx minus n1 into n1 plus 1 by 2. It is a factor. You are subtracted a factor. Actually, it is the mean. You subtracted the mean from Tx because this is a binomial situation. You are ranking the you are considering the sides, plus and minus sides. Plus minus, it means it is binomial. Okay. So it is Tx minus its mean n1 into n2, n1 into n1 plus 1 by 2. Similarly for Uy, it is Ty minus n2 into n2 plus 1 by 2. Okay. Now the test statistic U is the smaller of Ux and Uy. In Wilcoxon test statistic, T is smaller of Tx, T plus and T minus. Here, U is smaller of Ux and Uy. Okay. This statistics can also be defined as Ux is, we can use this formula also. Ux is N1, N2 plus N2 into N2 plus 1 by 2 minus Ty. This is a formula connecting with the X and Y. Similarly, Uy is n1 n2 plus n1 into n1 plus 1 by 2 minus tx. You can use this formula also. Okay. And here you can note that the sum of ux and uy. Using these two equations, you just find out the sum ux plus uy, which is equal to n1 into n2. Similarly, tx plus ty, you will get this expression. Okay. Now you may consider a problem how we can use this testing, man-made testing in a practical situation. Okay. So the problem is compute UX, UI and U for the following samples. So you may find out the U statistics for X, Y and uh, uh, smaller value, that is U. Okay. Here you have two sets of data, X and Y. X is having 4 observations and Y is having 7 observations. Okay. So these are two independent groups. Okay. So first you have to pool these observations. You have to combine these observations and find out the smallest one. You arrange the observations from the smallest one to largest one. So the combined data here, in the table you can see that the combined data the least value is 8, least value is 8, up maximum value is 65. So this 8 is coming from Y. Next value 10 is coming from Y. Okay, this is from Y, 23 is from X. Okay, and you put ranks to this observation. So ranks are 1, 2. Here, if any ties occurs, what happens? You find out the average of ranks and substitute that ranks to the tied observations. Okay, here tied, that is why it is 6.5, 6. These two observations are equal 32. 132 is coming from X and the other is coming from Y. So its average is 6.5. You just put that values to these observations. Okay. Now goes to the next step. You have to find out Tx and Ty. Tx means sum of the ranks of the first sample. So for the first sample, for the X sample, you add its ranks. Here it is 4, then 6.5, 8, okay, 10, then 11. Okay, not 11, not 11. Only up to 10. Okay. So you find out the ranks correspond to X values and add all these values. Add all these values, you will get 28.5. Similar way, you find out the ranks for TY, ranks for second observation and find TY. TY is 37.5. TY is 37.5. Okay. Now, what is the next step? So you know what is N1, what is N2. N1 is size of first set, it is 4, N2 is 7. Now use the formula to find out UX and UY. For UX, it is Tx minus N1 into N1 plus 1 by 2. That is Tx is, what is Tx? 28.5. So 28.5 minus this value, it is 18.5. Similarly, UY is Ty minus N2 into N2 plus 1 by 2. So that value is 9.5. So what is U? U is the smaller value of UX and UY. Here smaller value is 9.5. 9.5. So the test statistic U is 9.5. So there is an alternative method because we have already said that there is an alternative formula for UX and UY. You can use that formula also. You will get the same results. Okay. Now we want to test how to use this U test for small samples and for larger samples. Okay, that we can discuss in the coming section because the time is over. So thanks to all. If you have any doubts in this discussion, that you can share with me. Okay, thank you.